Hi folks, Dr. P here. This is question 18 from the probability assignment. A bag contains 6 blue marbles and 10 yellow marbles. 2 marbles are drawn from the bag without replacement. Determine the following using the multiplication law and permutations or combinations. So in A here, we want to determine the probability that both marbles are blue. So just a little word about notation here. So there are going to be 2 different P's appearing here. This P here, well, that represents probability that both marbles are blue. But when we're dealing with permutations, well, we're also using P there, right? Remember, we can write permutations, right? We have N and we have R, right? That's also a P. So just to be a little bit clearer here, I'm going to be referring to probabilities by PR. And it'll be obvious in a minute here once we get started, what that means. So let's start with A. And let's start by using the multiplication law. So probability, so PR for probability here, just to be clear. Okay, so we want to determine the probability that the first marble is blue and the second marble is blue. Okay, so both are blue. Okay, now these are dependent events, so that we need to determine this by determining the probability of the first marble being blue times the probability that the second marble being blue, given that that first marble is blue. Okay, if we plug in some numbers here, well, the probability of a marble being blue, well, there are 6 blue marbles, right? And there are a total of 16 marbles. Okay, we start with a total of 16 marbles. So that means that the probability of a marble, a randomly selected marble, will be blue is 6 over 16. Okay. Now, what's the probability that the second marble is going to be blue if the first marble was blue? Well, if the first marble was blue, that means we only have 5 blue marbles left to choose from. And how many marbles do we have left in total? Well, 15. Okay. So if we multiply this out, we're going to get 6 times 5 is 30. 16 times 15 is 240. We can divide numerator and denominator by 30, and we're going to get 1/8. 1/8. That's our probability of both marbles being blue. So that's using the multiplication law. We can also do this using permutations or combinations. So in this case, this would be an example of permutations. So the probability of both marbles being blue, so blue and blue, is going to be the number of favorable events. Well, so order doesn't matter, order does matter here. Okay, so it's going to be permutations. We have a total of 6 blue marbles to choose from, and we're choosing 2. So these are the number of favorable arrangements, divided by the total number of permutations, which is going to be 16 P, and we're choosing 2, so 16P2. Okay, and if we evaluate this, we're going to get 1/8. All right, so think about the numerator as the number of favorable arrangements So favorable arrangements here will be, we're picking 2 marbles, and the denominator here being the total number of arrangements. Okay, so that was A. Let's have a look at B. The probability that the first marble is blue and the second one is yellow. Okay, so it's going to be probability of the first marble being blue, so B, and the second one being yellow. Okay, So I'm not going to write out this formula here, but we're going to use the same logic here. So for the first marble, which is going to be blue, we have 6 blue marbles to choose from out of 16, a total of 16 marbles, times the second marble has to be yellow. How many yellow marbles do we have to choose from? Well, we have 10 yellow marbles. We have 10 yellow marbles to choose from out of a total of 15 marbles. We started with 16. We picked out the blue, which means we have 15 marbles left. Okay. And if we evaluate this, we're going to get, well, we can sort of reduce this a little bit here, but we can divide... we can write this, we can divide by, 2, right? So we're going to get 3 over 8 times, we can divide by 5, we get 2 over 3, which is 6 over 24, which can be reduced to a quarter. So 25% chance that this is going to happen. Okay. We can also use the permutations here. So the probability, and again, order matters. The first marble has to be blue, right? So probability of the first marble being blue and the second one being yellow. Okay. So in the numerator, we want to have an expression using permutations for the total number of favorable arrangements. Well, we're picking 1 blue marble out of 6. So 6 P1. Okay, times, and then we're picking 1 yellow marble out of 10, so 10 P1. And the total number of arrangements is going to be just like up here, 16 P2. And if you evaluate this, you're going to get a quarter. Same as before. So these obviously, whether you use the multiplication law or using the permutations or combinations, as long as you do it correctly, you should be getting the same answer, obviously, right? And then finally in C, 1 is blue and 1 is yellow. So let's see, I'm going to try and fit it here. So in C, so there are actually 2 different scenarios here. One scenario is the probability of the first one being blue and then the second one being yellow. And then we have another probability here where the first one is yellow and the second one is blue. So they're not specifying the order. So we need to find both of those probabilities and add them up to get the total probability. Okay. And if we use the multiplication law here, so for we're going to write this out in one go here. So the probability of the first one being blue, well, we have 6 blue to choose from out of 16, so 6 over 16 times, and then a yellow, so there are 10 yellow, and now we have 15 left. So this is actually the same as this right here, right? And you may or may not realize that this second part is going to be the same, but we will do it. Plus the probability of the first one being yellow, well, there are 10 yellow, and there are 16 marbles to choose from, times, and then we have the probability of the second one being blue, well, there are 6 blue, but now we only have 15 marbles left. So if you evaluate this part here, that's going to be a quarter. This is also going to be a quarter, which is 2 over 4, which is the same as a half. So 50% chance. And then finally, let's do this using counting methods here as well. So in this case, it's going to be a combination, okay? Because order doesn't matter. We can pick the blue first or the yellow first. It doesn't matter. So we're going to write the probability of blue and yellow. Okay. The total number of arrangements where we pick blue marble combination is going to be 6C1. We don't care about whether it's coming first or second, so the order doesn't matter. Times the total number of combinations of picking one yellow marble is going to be 10, choose 1. And then the total number of combinations here is going to be 16, choose 2. And if you run this through a calculator, you'll find that it's also a half. Okay, I hope that helps.